Hey everyone, and welcome to our 8th video of the object-oriented programming portion. Today we're going to talk about recursion. So recursion is the idea of using a function to call itself. These functions utilize the computer's call stack. We have not covered what a computer's call stack is, so we're going to cover that in a second. Each function call that is added to the call stack is to be executed later. Some can even have additional code after the recursive call. And within the recursive call, we must have an instance to break us out of this recursive call. This is called a base case. You want to think about it as a break case. This is a case that breaks you from your recursive call. Now we have a stack. So this is a structure that is used within the computer. So these function calls are utilized on the call stack, and what that is you want to think of it as a structure like this that utilizes the first in, which is here, last out method, which means that everything is stacked on top of it. Every new item is placed on top. So the last item placed on top here is going to be the first item taken off, and then popped off, and then this item popped off, and this item popped off. Now these two items here, this was the first and second item placed in our stack, and looking at it, that would be the second to last item popped off and the last item popped off. So the last in was the first out, and the first in is the last out. So you want to think of this as like a stack of pancakes. So if here I have the big plate, and on top of my plate I make a pancake and I place it here, and then I go and make another pancake and I place it here, and then another pancake, and then another pancake, and then another pancake, and then another pancake. And then I tell other people to come grab their pancakes. So the first person comes over and they grab their top pancake and they eat it. The next person comes over and they grab the top pancake and eat it. The next person, top pancake, eat it. Top pancake, eat it. Now, top pancake, eat it, and we have one pancake left, and it was the first pancake made. So the first pancake to be made is going to be the last pancake to be eaten. That is the last in, first out, or the first in, last out. And that is how this stack is utilized. So now let's get into a recursive code example. So here we have just add all previous. So the function returns an int, add all previous, takes in a number, an int number, and here is the base case right here. Base case is here. So if number equals 1, return 1. This breaks us out of our recursive function call. Now, the recursive function call would be when this base case is not met. So when the base case is not met, we're going through our else statement. Our else statement returns the number, which is 5, because that's what we have here, where it calls the function. It calls with the value of 5. So the function number, so the value of number is 5, and then we have the add all previous function call plus add all previous function call on number minus 1. 5 minus 1 is 4. So now in our call stack, we go and we place add on 4. Now we go back to the top, and now we are calling, we are now at the value of 4. So we are now running through the add all previous again, but this time int number equals the value of 4. 4 does not equal 1, so we skip the if, we go right to the else. Then it is number of 4 plus add on 3. So it is add on 3. Next, we are back at the top. Now we have the number equals 3, so we are calling the function on add all previous with the number 3. 3 equals 1, that is false, so we go to the else. Return 3 plus add on 2. So let's go to our function call. Now we are on add of 2. So now we're back to our function. We are on add of 2. We are on 2 plus add of 1. So now we go and we add of 1 onto the stack. Now we are on the value of 1. Now this is where things get different. Now this is where our base case is met. So if 1 equals 1, this is true. So now this is the first time where our base case is met. 1 equals 1, this is true. So now we're going to return 1. So we have to see what that looks like for our stack. Now over here, we are now going to pop this off the stack. And now this all holds the value of 1. So all of this holds the value of 1. And this is done. We've executed everything, so 1 is popped off the stack. Oops. 1 is now popped off the stack, and it returned the value of 1. Now, from here, we now know that this returned the value of 1. That's what we just found out. But we are now back to our add on 2. When number equaled 2, it was calling it on 2 plus add on 1, and we know add on 1 equals the number of 1. So add on 1 plus 2 gives us the value of 3. 3 is going to be returned back to the return type of int, which happens to be here. So now we are popping this off the stack because we just completed it, and this returns the value of 3. Now we're over here, and now we are on the instance of 3. So the number equals 3. Number equals 3, and we just called on add of 2, and we know add of 2 equals the value of 3. So 3 plus 3 equals the value of 6. So this gets popped off the stack, and this returns the value of 6 back to the user. So now we're back here, and we know that we are now on the value of 4. So we're on 4 plus add of 3. We know add of 3 gives us the value of 6. So we have 6 plus 4 gives us 10. Now we're returning 10. So we pop the 4 off the stack, gives us the value of 10. Oops. Oh, and I made a small mistake in the beginning. I forgot to mention that when you have a yeah, that works. When you have a function and you add it in the beginning, like when you call it initially, like when it gets called, like for instance from right here, that I should have added the add of 5 on the stack, because that's the first call to be made. So this is the first call that should have been added to the bottom of the stack, which is what I'm adding right now. So now we pop this off the stack, and we know that if we are adding them all together, that add of 4, so we are at 5, and add of 4 returns the value of 10. 10 plus 5 gives us 15, and we just pop the last item off the stack, 15. So this entire function here, now that we're done with all of our recursive calls, our stack is completely empty, so we are done with everything in our recursive function call. The way we know that we're done, when our stack is empty. Our stack is now empty. Everything that we've added to the stack has been emptied from the stack. That means our recursive calls are over, and this here returns the value of 15 back to the user. 15. So when they see out, they're going to return 15 back to the console. Sweet. Now let's jump to the next one. Very, very similar. The only difference is multiplication. So I'm going to go through this one much faster. So we'll do the same thing. First we want to do is we want to create our stack, and we're calling it on mult of 6. That's the first thing we do. When we get here, we are calling it on mult of 6. So we come over to our stack, and we are calling it on mult of 6. So now we know that number equals 6. This is our base case. Same base case, when number equals 1, we are going to break out of it. So 6 equals 1, that is false. Let's go to our else. We have 6 times molt of 5. So I'm going to jump through this very quickly, and I'm going to tell you that we're going to call on molt of 5, and then we're going to call on molt of 4. I'll try and write a little bit cleaner. Molt of 3, molt of 2, molt of 1. This is where it gets interesting. So when we reach molt of 1, that means we have called it continuously over and over. The value here now equals the number 1. 1 equals 1. This is true. So we are going to return the value of 1. So over here, this is going to be popped off the stack, and it's going to return. I'm going to use a different color. This is going to be popped off the stack, and it's going to return the value of 1. Now, this is going to be, so now we are back on the value of 2. So the number here that we're calling on, the function we're referring to is 2, times molt of 1, which actually equals the value of 1. And we know 2 times 1 equals 2. So it is going to return 2 back to the function that called it. So that gets popped off the stack, and like we said, it's going to return the value of 2. Now we are back referring to the number of 3. So the function that we are on now is 3. So we can erase this. So like we said, number is 3 times molt of 2, we know equals the value of 2. 3 times 2 equals 6. So now this gets popped off the stack, and it returns the value of 6. Now we are referring to the number of 4. That is the function that we are on. So we have 4. 4 times molt all priv of 3 equals 6. Molt all priv of 3 equals 6. 4 times 6 equals 24. Now we have equals 24. Now we have 5 times molt of 4 equals 24. This would equal 120. 5 times molt of 4 equals 120. Equals 120. Then pop this. Molt of 4, 120. Lastly, we are on 6. 6 times molt of 5. Molt of 5 equals 120. Let's see what the calculator has to say. I'm not going to do that math in my head. 6 times 120, 720. Probably should have been able to do that. So we pop that off, equals 720. Sweet. So we refer back, and this equals 720. Awesome. Okay, next we have some recursive code. So in our recursive code, we have a palindrome. So this palindrome is pretty interesting. So what we have to do is have it return it's not returning anything because it doesn't have a, well, it does have a return type of 0, but that's for the base case. It's not actually returning anything in main is what I was getting at. But it's going to print everything out so we can see what it looks like before its recursive call and after its recursive call, which actually does make a palindrome. And for those of us that know what a palindrome is, that would be something that equals the same thing both ways that it is written. So when it is written forwards and when it is written backwards, it equals the same thing. So let's get into an example of that. Let's give the number of 5 that we're passing in. So first let's come over here and let's create our stack. Hopefully we made that big enough. Same thing we want to do. First thing we want to do is add the make palindrome 5. So I'm just going to call it actually I don't want to write the same thing every time. We're just going to call it P for our palindrome. And first thing we're doing is we're calling it on 5. So we're over here, we're calling it on 5. This is our base case. So we have our before number. So now we are printing. So here is going to be our console area. Console. So before is going to be, I should have done number before. Instead I just wrote before, saved myself some strokes. So before, and then the number that it's printing is going to be the number 5. And then it's going to make the recursive call of the make palindrome, calling in number minus 1. So now it's calling in on 5 minus 1 is 4. Now it's making the recursive call of P of 4. But let's think about this. We just finished this line of code. We made it, well, we didn't finish it, but we checked it, so we satisfied it. And then we went to this line of code and we executed it, so we satisfied it. And then we did this line of code, but that line of code hasn't come back yet. So notice that this line of code here is left out. It has not been executed yet. So when our make palindrome recursion call comes back, it needs to come back and execute this line of code right here. So that is something to think about. So in this call here, this still has one line of code to execute. Just something to think about. So we are now just called it on palindrome of 4. So now we're here and we are calling it on palindrome of 4. Again, 4 is not equal 1, so now we are calling it on before on 4. So then we make another call on P of 3. Now P of 3. So 3 does not equal 1. Good. Now we're calling it on number of 3. And now we are making another recursive call here. 3 minus 1 is 2. So we're calling it on palindrome of 2. So now we're up here and we are on 2. 2 equals 1. That is false. So then we go to the cout and then we print before 2. Then we make our palindrome, and it is 2 minus 1, so we are calling on palindrome of 1. Palindrome of 1. Now we are meeting our base case. So this is the first time, we're on palindrome of 1. Now this is the first time where 1 equals 1. This is true, so we are going to return 1. Okay, so up here, we now want to come back and return 1. So this gets popped off the stack, and it returns the value of 1. But let's note that it's because this does not have a return, it's not returning anything. It doesn't even have an opportunity to return to something. The return that it just made falls nowhere, so it doesn't get grabbed by anything. The fact is it just made that call. But let's note that we did not finish these last lines of code. So now we are back on the number equals 2, so we were referring to the number 2 function, and we have executed this line of code, we've executed this line of code, we've executed this line of code completely now. We still have to execute our last line of code. So now we have after. We notice that this says number before and this says number after. So we have after, and the number that we're referring to now is 2. So now we have completed all lines of code. I've completed this line of code, completed this line of code, completed this line of code, completed this line of code. I've completed everything for, let's change the color, for this palindrome 2. So because I've completed everything, I pop it off the stack. Now I come back and I am referring to the value of 3. So I have completed this line of code, I have now completed this line of code, and it's just returned back to me. I still have to complete this line of code. So how do I do that? I just print after, and I am referring to 3. Now I have completed this line of code, completed this. Now I can go back to my stack and I can pop it off. Pop this off the stack. Now I'm referring to number equals 4. So again, completed this line of code, I have now just completed this line of code, and let's do the last one. The last one being after 4. So we have number after and the value of 4. So, whoops, meant to erase all that. So we are done with that now. We have just completed all lines of code for 4. So now we come over to our stack and we pop 4 off the stack. And now we're on our last item of 5. So now we want to print, do it in our green, after 5. So now we've completed all the lines of code. We come over here, pop this item off the stack. We've popped everything off the stack. Our stack is empty. Because our stack is empty, we have made all lines of code we've executed all lines of code to be executed. We are now done. So we've popped everything off the stack to be completed. There's nothing to return. There's nothing that it can return here because there's no cout statement. So there's nothing that can be returned. There's nothing to return. Everything that this application does is print. It'll print number before, and then 5, 4, 3, 2, and then it'll print number after, 2, 3, 4, 5. So it makes a palindrome. 5, 4, 3, 2, 2, 3, 4, 5. That's the palindrome. So we just used a palindrome for recursion. And lastly, here's how we get help if needed. All right, and here is our build and run of the 3 things that we just did, which was our palindrome, add all previous, and multiply all previous. So up here they're not in the correct order, but down here they are. So first we're doing add all previous on 5, and then we're doing multiply all previous on 6, and then we're doing make palindrome on 5. So, spelled recursive wrong. Okay, so I've already ran it over here, but let's see what it looks like. So add all previous on 5. So again, what it's doing is it's recursing all the way to the bottom until it gets to the value of 1. And then from 1, it's returning 1 and adding 1 to 2. And then adding 3 to 3. And then adding 4 to 6, yeah. So on and so forth until we get all the way to 5, and then it's adding 10 to 5 to get us to our value of 15. So again, it makes all these recursive calls until it gets the value, and then the same thing for multiply all previous with the value of 6, but of course it's recursing all the way to the bottom to do 1 times 2, and then 2 times 3, and so on and so forth until we get all the way to 6 times 120, recursing all the way back. And then lastly, we have our make palindrome, which is over here. So we have all the numbers before, number before 5, number before 4, number before 3, 2, and then it comes back after it pops everything off the stack to number after 2, number after 3, number after 4, and number after 5. So we'll just run it once more. So we built it and we ran it. So we get the value of 15, the value of 720, the value of 5, 4, 3, 2, and 2, 3, 4, 5. And I can come over here and change the base case in the make palindrome. So if I make the base case 0 and the return 0, this would make it so now my palindrome is going to go down to 1. 5, 4, 3, 2, 1, 1, 2, 3, 4, 5. So let's save it, build it, run it, and let's watch our palindrome include the ones. 5, 4, 3, 2, 1, 1, 2, 3, 4, 5. Awesome. So, hope that made sense, and see you in the next video about STLs.